2.4, zeros of polynomial functions. We start off with something called the remainder theorem. F of k is equal to the remainder of f of x divided by x minus k. This we usually call a factor, where k is a zero. So there's going to be this relationship between zeros and factors, and we're going to see it over and over and over again. So what I'm really trying to do is divide that function by the factor. And I'm not going to do long division, even though we could. I'm going to do a process called synthetic division. Maybe you remember it. But the zero, in this case, is 4. That's your zero. So that's the number you want to use. And what I'm going to do, I want you to draw a box, kind of like this, and make sure you've got enough for two rows of numbers. And the top row of the numbers is going to be the coefficients in this problem. I see a -3 for the x to the fourth. I see a 15 for the x squared. Now notice, I said x squared, but I meant x cubed. Notice x squared is missing. So you have to put a 0 to hold its place. If you don't put a 0 as a placeholder, you're going to get confused. Your numbers are going to get crossed up. So each term has to be represented. -3x to the fourth, 15x to the third, 0x squared, minus 50x, and then 25. So again, you've got this box, and underneath the row of numbers I just wrote, make sure you've got enough room for another row of numbers. All right? So the synthetic division process is a simple process, much simpler than long division. But the process is step 1, we're going to add down. And step 2, we're going to multiply diagonal. And you'll get it. It's hard for people at first, but you'll get it. So first number we start with this is -3, and there's nothing to add it to, so just bring it down. But add down, you get -3. And then when I say multiply diagonal, I'm talking about like this number times this number. 4 times -3 is -12. And I write it down right there. All right, just keep doing those steps over and over again. I'm going to add straight down. 15 plus -12 is 3. And then when I say multiply diagonal, I'm talking about 4 times 3 right there. I'm multiplying that number on the left times my number down there at the bottom. 4 times 3 is 12. Keep doing the steps. Add down, you get 12. Multiply diagonal, 4 times 12 is 48. Add down is -2, multiply diagonal is -8. Add down, 25 plus -8 is 17. That's my answer right there. The remainder theorem. That's the remainder of the division problem. All right. And without going into the long division process, that's the remainder. That's the answer. And that means f of 4 equals 17. Now, if you're thinking about it, you're like, well, why in the world would I do that when I could instead just plug in, and I could plug in 4. All right. So the equation said, or the function said -3, and I'm plugging in 4. So to the 4th power, or was it? Plus 15 times 4 to the 3rd power minus 50 times 4 plus 25 gives us 17. We plug in 4, we get 17, all right? And so a valid question would be, why in the world would I want to use this synthetic division process to get 17? Why just plug in the number, I get 17? That's a valid question. That's a good question. But the answer to that question is, even though we don't necessarily need to do it, it's interesting that we can do it, and it shows us some relationships. It's the remainder of the division, but the remainder of that division problem is also, it just happens to equal what we would get when we plug that 0 in. All right, so that's useful to know for a lot of the other things that we do. The next little box says if k is a solution or root or 0 of that function, then the remainder of the division is 0. So example 0b says determine if -3 is a 0 of this function. Well, let's just do that synthetic division again. We got 1x to the fourth, -4x to the third, 0x squared. Make sure you put a placeholder in there if it's a missing term. Plus 36 x plus 45. So again, it's the same steps. It's the same process. Add down, you get 1. Multiply diagonal is -3. Add down -7. Multiply diagonal is 21. Add down is 21. Multiply diagonal is -63. Sometimes you get really gross, ugly numbers, and it's hard to do. Use a calculator if you need to. Add down. So 36 plus -63 is -27. And then multiply diagonal. -27 times -3 is 81. And then add down. 45 plus 81 is 126. Now, this number is the remainder, but it is not the answer to this question. It says determine if. So the answer to this question is a yes or a no. Determine if it is a 0. All right? So if it is a 0, well, it is a 0 if the remainder equals 0. So since the remainder does not equal 0, then we can say -3 is not a 0 of that function. You know, and you could just have easily have plugged in -3. You plug in -3 into the function. What's it going to get on my calculator if I plug in -3? 126, right? 126. In order for that to be a 0, we would have to get 0. So, you know, if you think about it, we had two different things, two different blue boxes or whatever, and we used synthetic division to answer both of them, even though they were asking two different questions. All right, we got a lot of stuff in this lesson that's kind of similar, and we'll be using synthetic division to answer a different question next time. Factor theorem. X minus k is a factor of the function if and only if f of k equals 0. So it's really kind of saying the same thing. If that remainder is 0, you're looking at a factor. So determine if x plus 4 is a factor of each function. Well, x plus 4 is the factor, potentially. So -4 is the 0. We can say k equals, I guess, if you want. Think about what number makes x plus 4 0. That's -4. So -4 is our number that we want to use. -4 is the number that we want to use. X plus 4 is the factor that they're talking about. Those two things are related. You're constantly going back and forth. So determine if x plus 4 is a factor. We can do that by determining if -4 is a 0. 3x to the fourth minus 48x to the third plus 0x squared plus 8x plus 32. So really, it's the same thing. Add down is 3, multiply diagonal is -12. Add down and you get -60. Multiply diagonal, you get 240. Sometimes when your numbers get so ugly and so big, you can get a feeling for what the answer is going to be before you get there. I feel like this is not going to work. Add down and you get 240. Multiply and yuck, that's -960. Add down, 8 plus -960 is -952. Multiply times -4, yuck, that's 3,808. -4 times -952 is 3,808. If you add straight down 32 plus 3808, we get 3840. That's the remainder, but that's not the answer. The question was determine if this thing is a factor, okay? since that remainder is not equal to 0, remember, we're looking for a 0, right? Since that remainder is not 0, then we can determine x plus 4 is not a factor. So we really want that remainder to be 0. So we look at part B. Maybe it'll work this time. Same thing. We want to look at the 0. You don't use the plus 4 in the factor. You use the 0. Negative 4 plus 4 is 0. So 1x to the 5th, 6x to the 4th, 11x to the 3rd, 12x squared, 5x, and minus 20. Notice I didn't need any placeholder zeros this time. Same process. Add down and multiply. Add down is 2 and multiply is negative 8. Add down is 3 and multiply is negative 12. Add down is 0 and multiply is 0. Add down is 5 and multiply is negative 20. Add down, that's not 0, that's negative 40. Shoot. Okay, I was really hoping that was going to be 0. But that remainder there is negative 40. That tells me that x plus 4 is not a factor. It's only going to be a factor if the remainder turns out to be 0. So that's what we're looking for. We're looking for a remainder of 0. We didn't get that. Okay. By the way, who can tell me what g of negative 4 is? G of negative 4 equals negative 40. I don't need to plug that in. It's just whatever that remainder was. That's the remainder theorem. Okay. Example 2. Factor 6x cubed minus 37x squared plus 32x plus 15 into linear factors given that 5 is a 0. Now, this problem is huge for us as algebra students because you spent a lot of time in your life factoring, but you probably couldn't do anything like this before. You pretty much spent your time on x squared problems. You factored a lot of x squared trinomials, and maybe they were difficult, but they probably weren't this difficult. But this process is going to allow us to factor a lot more stuff that you've never been able to do before. All right, so a lot of the stuff we do is review, but this is really important because this will allow you to factor a lot of things. So it's important that they tell me that 5 is a 0. Okay. 5 is a 0 tells me x minus 5 is a factor. I don't really care about that. What I'm going to do is I'm going to take that 5 and I'm going to do synthetic division on that 5. All right, synthetic division on that 5. So I've got 6x to the 3rd minus 37x squared plus 32x plus 15. Don't need any placeholders. I'm going to add down and get 6. I'm going to multiply and get 30. Add down is negative 7. Multiply is negative 35. Add down negative 3. Multiply negative 15. Add down 0. All right, there we go. That's the first one we've had a remainder of 0. Okay? But when we're talking about division, that means that it divides in evenly. Think about back to 4th grade when you first learned about division. If the remainder was 0, it divided in evenly. That's what we've got here. None of the other ones divided in evenly that as far as we've seen today. But this one does. Okay? And so if you think about it, and this is kind of hard to process, but think about this. Knowing that 5 is a 0 means that x minus 5 is one of the factors. And that's what we're trying to do after all is factor the problem, right? We're trying to factor that polynomial into x plus 5 or x minus 5 times whatever else, okay? But what we are doing in this process is dividing. And so if you divide, I want you to think about this. If I divide 6x cubed, oh my gosh. It does not want me to draw exponent 3 there. minus 37x squared plus 32x plus 15. If you're dividing all of that by x minus 5, now there's more than this going on, but if you think about just the first term, okay, there's a lot more than this going on, but let's kind of just think about if I had 6x cubed divided by x. If I just boil that problem down into just this little bitty piece of that problem, one of the x's canceled out and we get 6x squared, right? Right? 6x cubed divided by x is 6x squared, right? That's kind of what we've done. There's more to it than that, but that's kind of what we've done. And in this problem, what we've done with our synthetic is we've divided off an x off of the polynomial. And so your x cubed became x squared, and your x squared became an x term, and your x term became a constant term. And then your constant term would have been the remainder, or would have turned into the fractional part or the remainder part, but since it's 0, we don't have to worry about that piece. It divides perfectly, and our result was 6x squared minus 7x minus 3. And that is something that you should remember how to factor from last year, year before, whatever. Now, I know people are not real solid at factoring something like this, but think about, I call it a hard trinomial. 6x squared has to come from either 6x and x or 3x and 2x. Some teachers call this unfoiling, all right? If you think about unfoiling the problem, okay, go backwards from what I have as my answer. You know, if you distribute that answer back to 6x squared minus 7x minus 3, we can kind of reverse engineer this process. A lot of times we think about what multiplies to this, what multiplies to negative 3. So if you look at 3, there aren't very many possibilities of numbers that multiply by 3 or up to 3. Now, I know it's a negative. And so that tells me that one of the two numbers is negative, but I'll kind of hold on to that information for a second, all right? When we factor, we a lot of the time say, what multiplies to negative 3 and adds up to negative 7? All right, but that was when we factored an easy problem. This is a harder problem. I call it a hard trinomial. Those two numbers do not add up to negative 7. You can't say 1 plus 3 is 7. But the reason why is if you think about the distributive property and the way this works, the reason that's not going to add up to negative 7 is because we are distributing a 3 and a 2, it turns out. The 6 and the 1 isn't going to be the right answer. And so what you have to think about is, how can I multiply one of those two numbers by 3 and the other number by 2, and then they'll add up to 7? Okay? And that's hard to get at first. But if you think about, if I said 3 times 3 was 9, and 1 times 2 was 2, and I subtract those two numbers, that's going to give me 7. 9 minus 2 is 7. That's my whole process. Okay? Now remember, I need it to be negative, though. And I need it to add up to a negative 7. So if I make this negative 3, that'll be negative 9 plus 2 is negative 7. Okay? So what I have to think about is this number over here is getting multiplied by this 3. So that means, since this number is getting multiplied by 3, I put a minus 3 on this side. And this number right here is getting multiplied by 2. So since this number is getting multiplied by 2, I'm going to put a plus 1 right there. Do I want you to write this down? Yeah, you write pretty much everything I write down. All right? You're writing down what I write down. Okay? That is factored. Now don't forget, we started with this first factor. They gave me this one, x minus 5. But then I figured out the other two factors, 3x plus 1 and 2x minus 3. Factors. Now, if you didn't understand that, you're not alone. It always takes people a while to feel comfortable with that process. But you're going to see it again, and you're going to see it again. You're going to see it a few times. You've got to get to where you're comfortable with that hard trinomial factoring process, because that's a thing, all right? Now, also, I want to point out there is a relationship between zeros and factors. Remember that factor of negative 5, or x minus 5 had a 0 of 5. Okay. 3x plus 1 has a 0. Think about what would make that 0. What number would make that 0? It's not negative 1. It's negative 1/3. And what number would make this 0? Is positive 3 over 2. Now, that's not the answer to this question. That's just useful to know because we're constantly switching back and forth between we need to find zeros and we need to find factors. Now, looking around, most of you are tuned in, but I see a couple people that are not tuned in. This is way too difficult of a concept for you to be tuning me out right now. All right? This is not simple. There's a lot going on here. You need maximum focus. All right? Let's continue. Rational zeros theorem. If this polynomial has any rational zeros, they must be of the form plus or minus p over q, where p is a factor of b and q is a factor of a. I don't know where my of went. What we're trying to get to is where we can factor really complicated stuff. All right? And number 3a is a lot harder than the last one because we're trying to factor it. Look at 3b. We're trying to factor that problem, but they didn't give me anywhere to start. All right? And so the rational zeros theorem just kind of gives me a starting point. It gives me some numbers that I could possibly try and see if those are actually factors or not. All right? Or possible zeros or not. So what they're saying here is this number is p and this number is q. P is 4 and q is 8. All right? So if this polynomial has factors, it's going to be some version of factors of no, I said that wrong. I'm sorry. This number is A, and this number is B. Okay? It's going to be some fraction that I can make out of B over A. All right? Those numbers. So first I have to find P. P is factors of 4. Factors of 4 are 1 and 4 and 2. I like to list it out as 1 times 4 and 2 times 2. That gives me all the factors of 4 are 1 and 2 and 4. I do the same thing with 8. I find the factors of 8. That's 1 and 8 and 2 and 4. All right, let me do this again. Let me do it in a different color. My possible rational zeros is going to be a fraction that I form plus or minus p over q. And so what I have to do, what that means is I have to take all of the blue numbers divided by all the red numbers. So let's start with the blue number 1. I said a blue number 1. 1. Divide by a red 1. Take your 1 and divide by a red 2. Take your 1 and divide by a red 4. Take your 1 and divide by a red 8. You've got to take all of the blue numbers divided by all of the red numbers. Next blue number I see is a 2. So I'm going to divide by a 1 and divide by a 2 and divide by a 4 and divide by 8. All of the blue numbers divided by all of the red numbers. That's our P over Q. Next blue number is 4. I'm not going to do 2 again. I already did 2. Next blue number is 4. So divide by 1 divide by 2, divide by 4, divide by 8. All right. Now, that's pretty much it, but let's kind of clean this up. Let's reduce our fractions here. 1 over 1 is 1. There's 1/2, 1/4, 1/8. 2 over 1 is 2. 2 over 2 is 1. We already got that one. We already got one. 2 over 4 is 1/2. We've already got that one. 2 over 8 is 1/4. We've already got that. 4 over 1 is 4. 4 over 2 is 2. 4 over 4 is 1. 4 over 8 is 1/2. So basically, I just want to say plus or minus these numbers. So I've got plus or minus. Doesn't really matter what order you list them out in. I've got a 1, 1/2, 1/4, 1/8, 2. Already got 1. Already got a 1/2. Already got a 1/4. Got 4. Already got 2. Already got 1. Already got 1/2. 1, 2, 4, 1/2, 1/4, 1/8, plus or minus. Okay, so what in the world did we just do? We just figured out that if there's something that works, if there's a number that is a 0, if there's a nice rational number that is a 0, it's got to be one of those numbers in the list. All right? Now, all of those numbers will not work for sure. Does anybody know how many zeros there could even possibly be in this polynomial? Very good. 4. That's right. You look at this exponent, that kind of is a clue of how many zeros actually will work. So all of those numbers will not work for sure. Hopefully some of them do. But here's the problem. We don't know which ones work and which ones don't. And so that's why we just have to kind of guess and check and try numbers until we can find something that works. Okay? So this is kind of the main event problem right here, 3b. We're trying to factor this polynomial. We're trying to factor it, but we don't really know where to start other than these numbers might work. Okay? So how do we determine if they work for sure? We're going to do that synthetic division process and look for zeros, like we did the first couple of examples. So the first number I see is positive 1. You've got plus or minus, and one of those numbers is a 1. So I'm going to try 1. Let's just see if 1 works. Right? Kind of small, because I'm going to end up doing synthetic division like 5 or 6 times. Okay? Right small. 8x to the 4th minus 26x cubed minus 27x squared plus 11x plus 4. You can work faster than me, feel free. Add down is 8, multiply is 8. Add down, negative 26 plus 8 is negative 18. Multiply is negative 18. At this point, I'm suspecting that it's not going to work. But let's continue. Add down, negative 27 plus negative 18 is negative 45. Use a calculator if you need to. Multiply is negative 45. Add down, 11 plus negative 45 is negative 34. Multiply is negative 34. Add down, negative 30. Negative 30. Because we are looking for zeros, but did not get a 0, that tells me that 1 is not a 0. The number 1 is not a 0, therefore it's not useful to me. Okay? Toss it out. Don't use it. So what else can we try? Something else in this list. I usually try to go in order from the easiest number to the hardest number. Is there a question? No? So the next easiest number for me to try is probably going to be negative 1. So I just start over. 8, negative 26, negative 27, 11, and 4. Add down, and that's 8. Multiplies negative 8. Add down, negative 26 and negative 8 make negative 34. Multiply, negative 1 times negative 34 is positive 34. Add down 7, okay, maybe. Multiply negative 7. Add down 4, multiply negative 4, add down 0. Perfect. That's what I want. Check. Okay, that's good. That tells me that negative 1 is one of my zeros, or it also tells me that x plus 1 is one of my factors. I'm trying to factor this problem. There are going to be 4 zeros or 4 factors. I just found one of them. All right. Now, the process is division. And so what we've just done is we've divided off an x. And so the bottom line here is we just reduced our polynomial down to x cubed minus 34x squared plus 7x plus 4. We just reduced it from an x to the fourth down to an x to the third. We still have to try to factor this. If we knew how to factor this, we would just factor it. If we don't know how to factor this, we'll continue the process. Okay? But don't start over with the original polynomial. Use the reduced polynomial. So right now I've reduced it down to 8, negative 34, 7, and 4. So make sure you're using the reduced version. Keep reducing, keep reducing, keep reducing. Okay? And one thing that's weird about this is negative 1 could possibly work again. It doesn't happen so often, but negative 1 we could try again. I'm not going to try that because I know it doesn't work again. I'm going to move on and try another number like positive 2. All right. So let's just see if positive 2 works. Positive 2. Add down, you get 8, multiply 16. Add down negative 18. Multiply negative 36. I'm not feeling good about this one. Add down negative 29. Multiply negative 58. That's not going to work. Negative 54 as my remainder does not work. Okay. I know that 2 is not a 0. 2 is not a 0. Maybe negative 2 is. Remember, I told you to write small. I'm still going to keep rolling with the reduced version. Don't go back to the start and start over. 8, negative 34, 7, and 4. Add down is 8, multiply negative 16. Add down is negative 50. Not feeling good about this. Multiply is 100. Add down is 107. Technically, as soon as you know it's not going to work, you can quit and give up. Multiply is negative 214. Add down negative 210. That's your remainder, but negative 2 does not work. Okay. I wouldn't recommend trying the fractions. Remember, 1/2, 1/4, 1/8 could possibly work. I just think they're harder to use. So I always try the integer numbers first if I can. 2 doesn't work. Negative 2 doesn't work. Maybe 4 works. Let's try 4. Again, I'm using reduced version. 8, negative 34, 7, and 4. Add down, that's 8. Multiply 32. Okay, maybe. Add down negative 2. Multiply negative 8. Add down negative 1. Multiply negative 4. Add down 0. Sweet. Okay, that works. Meaning 4 is a 0 or x minus 4 is a factor. I'm trying to factor it. There are 4 factors. I got x plus 1 and I got x minus 4 at this point. But I've also reduced the problem down. Okay? I've reduced it down again. It was x to the third. Now what is it? x squared. You're looking at 8x squared minus 2x minus 1 right there. This is something that you should be able to factor from Algebra 1 techniques. I know it's not the easiest thing to do in the world. People aren't awesome at it, but it's something that you should be able to do. 8x squared has to come from either 8x and x or 4x and 2x. One or the other. A lot of times people see one, but they don't see the other. You have to go through any kind of possible way of getting 8x squared. It's one or the other. So how the factoring process works is you look at that number on the right. It's -1, but just look at 1 for a second. Okay, forget about the negative. You can think about the negative later. I need two numbers that multiply to 1. Well, it's got to be 1 and 1. It's got to be. Now, you know, since it's negative, that means one of the two numbers is negative, but you can kind of figure that out later. All right? Those numbers have to add up to -2. And you're saying, well, if I do -1 plus -2, that's going to work, right? But that doesn't multiply to -1. That multiplies to +1. Okay? The thing you have to consider is, now I'm just going to go ahead and tell you that this one doesn't work. Both of them will not work. It's one or the other. One of them works and the other one doesn't work. But what happens is whatever comes over here is getting multiplied by 4. And whatever is over here is multiplied by 2. All right? So the process is one of these numbers is times 4, and the other number is times 2. And then they're going to add up to -2, that middle number. All right? It's kind of a lot to process. But in order to make one of them, well, it's got to make a -1, so one of them is negative. In order to make this -2, probably the one that's multiplied by the 4 is going to be the -1. Okay? -1 is times 4. So that means put -1 over here in the position that's getting multiplied by the 4. +1 is times 2, so put the +1 over here in the position that's getting multiplied by 2. You've got to remember how that FOIL process or that distributive property works in this problem. But that's it. That's factored. Okay, now go back and just put it all together. The first one we found was x plus 1. The next one we found was x minus 4. And then we were able to do Algebra 1 techniques. We have 4x plus 1. And, I'm out of room. Two x minus 1. Factored. That's tough stuff, guys. That's tough stuff because there's a lot going on there. All right, but it's basically just synthetic division and factoring. Now, again, later if they have us solve it, we should be able to solve or talk about zeros. There's a -1, there's a +4, there's a -1/4. It's always the opposite of that number divided by the front number or the number that makes 0, and +1/2. Fundamental theorem of algebra. Polynomials with degree of at least 1 have at least one complex 0. Okay, that's kind of harder to understand, I think, than the number of zeros theorem. Polynomials of degree n have at most n different zeros. For example, a degree 3 polynomial has 3 zeros, but those zeros may or may not be different. So that's kind of what we hinted at earlier. When you see an x to the third, you're thinking 3 zeros. When you see an x to the fourth, you're thinking 4 zeros. When you see an x to the fifth, you're thinking 5 zeros, and so on. Now, the kicker is they don't all have to be different. In the last example right here, the -1, the +4, those purple numbers over there, you've got 4 different zeros. But you might have repeated zeros. They might be repeated. Okay, number 4a. Switching gears here. Find a function f defined by a polynomial of degree 3, so that means x to the third, with f of -1 equals 24 and zeros, -3, -2, and +5. All right, this starts off okay, because a 0 of negative 3 means a factor of x plus 3. And a 0 of negative 2 means a factor of x plus 2. And a 0 of 5 means a factor of x minus 5. So when they say they want to find a function defined by a polynomial, we're going to distribute this out, okay? Distribute this, clean this up, get rid of the parentheses, that kind of stuff. So let's leave the x plus 3 alone and let's distribute here. X squared minus 5x plus 2x minus 10. This is old news, right? This is not rocket science. This is not new material. I'm just distributing. That's x squared, minus 3x minus 10. If you can skip a step and do that in your head, then be my guest. Okay, two numbers multiply, two numbers add up. But now what we have to do is another distributive property, because now we got to multiply the x plus 3. So think about it as distributive. Distribute an x to each of those three terms. You're going to have x cubed minus 3x squared minus 10x. And then you're going to distribute the 3. I like to write it like this: plus 3x squared minus 9x minus 30. I like to write it like this because my like terms are lined up. That gives me x cubed. The x squared terms cancel, and so I've got minus 19x minus 30. And that looks like that's going to be the answer, but the problem with that is we haven't used this piece of information yet. F of negative 1 equals 24. And if you think about it, if I plugged in negative 1 cubed minus 19 times negative 1 minus 30, if I plug that in, I get negative 12. Okay, negative 12. I'm supposed to get positive 24. I got negative 12. When I plug in negative 1, I'm supposed to get 24, so I'm off. By a factor of negative 2. Okay? If I'm supposed to get 24, but I got negative 12, let's just multiply by negative 2. Okay? Let's multiply by negative 2. And so what I'm going to do, my function is negative 2 times what I just got there. So distribute negative 2x cubed plus 38x plus 60. Find a function f defined by polynomial of degree 3 with f of negative 1 equals 24. If you plug in negative 1 right now, you're going to get 24. Guaranteed. Okay, let's go ahead and finish this one up. Example 4b is the same thing. Find a function f defined by polynomial of degree 3 that has a 0, 4 of multiplicity 3. Multiplicity 3 means it's repeated. In this case, 3 times. And so when they say it's a 0 of 4, that means x minus 4. But with a multiplicity of 3 means it's repeated 3 times. Okay? So we have x minus 4 times x minus 4 times x minus 4. Now I'm going to save you the multiplication, the distributive property, and that's going to turn into x cubed minus 12x squared plus 48x minus 64. All right? That's what you get when you FOIL that all out, when you distribute that all out. All right? So is that the answer? Well, not quite, because when we plug in 2, we're supposed to get negative 24. So if I plug in 2 cubed minus 12 times 2 squared plus 48 times 2 minus 64, if I plug in 2, I get negative 8. Where did I get what? Do I have a mistake here? When I plug in 2, I get negative 8. I'm supposed to get negative 24, so I'm off by times 3. I'm off by a factor of 3. So let's just take what we got and multiply by 3. 3 times x cubed minus 12x squared plus 48x minus 64 is going to give us our answer. F of x equals 3x cubed minus 36x squared plus 48 times 3 is 144. X minus 64 times 3 is 192. Conjugate zeros theorem. If a plus bi is a zero of a polynomial with real number coefficients, then a minus bi is also a zero. Here's something that looks a lot more complicated than it actually is. What it's saying is, if you've got some zero and it's got an imaginary part, so let's say it's 2 plus 5i, literally all that says is that it's also going to have 2 minus 5i. If one of those is a zero, then the other one is also a zero. Conjugate. That's what a conjugate is. Plus 5i, the minus 5i part. Number 5 says, find a polynomial function f of x of least degree having only real coefficients and zeros, negative 4, and 3 minus I. So here's this a plus bi form. That implies that there's also a zero of 3 plus I. So I see 3 zeros. 3 zeros, you should be able to translate that into factors. So the first one's easy. The real number negative 4 comes from a factor x plus 4. After that, you've got x minus 3 minus I and x minus 3 plus I. Now think about how that works. Your negative 4, I mean, people don't really think about that. They kind of do the first one in their head, but really you're thinking about it as x minus negative 4. That's kind of what you do, and that's why it's plus 4. X minus negative 4, that's x plus 4. So that's why it looks so complicated there with the x minus 3 minus I. So we need to multiply all that out. Just easier said than done. But let's distribute the negative. That's kind of where I would start. Distribute that minus, and that's x minus 3 plus I inside there. And I'll do the same thing, x minus 3 minus I right there. I want to distribute and multiply that together. Multiply the 3 things on the left by the 3 things on the right. And so that's distributive property. Let's distribute. The x would give me x squared minus 3x minus ix. And then I would distribute my negative 3. 1, 2, 3 times. I get negative 3x plus 9 and plus 3i. Notice how I wrote this down. I'm just trying to line up like terms. so it's easier to collect here in a second. Now I distribute the I 1, 2, 3 times. That's going to give me plus ix minus 3I minus I squared. We're going to collect like terms, but notice those two cancel out and those two cancel out. That's nice because that's getting rid of all my imaginaries. But also you want to notice minus I squared. Remember how I squared was negative 1? So minus negative 1 is going to be plus 1. At this point, I'm going to collect all my like terms. I'm going to have x squared minus 6x, and then plus 9 plus 1 makes plus 10. Now that's not finished because that's only what I got when I multiplied those two. I'm still going to need to multiply times x plus 4. So I need to do more distributive property. Distribute this x. I'm going to get x cubed minus 6x squared plus 10x. And then I'll distribute the 4. Get plus 4x squared minus 24x plus 40. Add straight down, x cubed minus 2x squared minus 14x plus 40. Find a polynomial function f of x of least degree having only, okay. So really that's all it told me to do. They only gave me those 3 zeros. If you look back a problem, they gave you that extra step, and we had to make sure when we plugged in 2, we got negative 24. And so we had to do a multiplier. We were off by 3. They don't give me that step here, so I don't have to do that extra step. This is my answer. Six, find all zeros given that 2 plus I is a 0. So the conjugate zeros theorem says that if 2 plus I is a 0, then 2 minus I is also a 0. So we have two different numbers that work. If you go back and look at, let's see, where was it? This problem. Remember when we tried to factor and we didn't know any possible numbers? We didn't know any of the numbers, so we had to figure out what could possibly even work. Well, that one was kind of hard. This one was easier because they told me one of the numbers that worked. They told me 5 worked, so I started with that. Well, in this case, I know 2 numbers that work, so I'm going to start with those 2 numbers that work. I'm going to do the same thing we've been doing, except I have to do it with an imaginary, which makes it a little bit more complicated. You've got 1x to the 4th minus 1x to the 3rd minus 17. Try to use some space, x squared, plus 55x minus 50. So same steps, add down and then multiply. Multiplying, you have to multiply 1 times 2 plus I, and that is 2 plus I. And then I add down negative 1 plus 2 plus I. You add your like terms, you're going to get 1 plus I. Negative 1 plus 2 is 1. Now when you have to multiply, this is kind of a pain because you have to multiply 2 plus I times 1 plus I. And most of us aren't very good at doing that in our head. So it's a distributive property problem, right? 2 plus 2I plus 1I plus I squared. I squared is negative 1, so 2 plus negative 1, that's 1 plus 3I. When I multiply diagonal, I got 1 plus 3I. That goes right there, 1 plus 3I. And I add now, negative 17 plus 1, that's negative 16 plus your 3I. And I have to multiply again. So I have to distribute again, 2 plus I times negative 16 plus 3I. Same thing, distribute. Negative 32 plus 6I minus 16I plus 3I squared. 3I squared I squared is negative 1, so that's going to be minus 3. That's negative 35 minus 10I. Yuck. Negative 35 minus 10I. I add down, that's going to give me 20 minus 10I, and I have to do the same thing again. I have to multiply. 2 plus I times 20 minus 10I. That's going to be 40 minus 20I plus 20I minus 10I squared. Minus 10I squared is going to be plus 10, because that's negative 10 times negative 1. That's plus 10. Notice these i's cancel, which is useful, which is nice, and 40 plus 10 is 50. I'm going to get 50 for that answer, which is good, because when I add down, I get 0. But we knew we were going to get 0 because they told us it was a 0. They told us 2 plus I was a 0, so you better get 0 there. But what we're going to do now is we're going to do the problem again using the second 0 that we found using the conjugate zeros theorem. So I'm going to use, since I already have what I need written down, I'm just going to use it right there. Well, I need the 1 and the 1 plus I, negative 16 plus 3I. So I've already reduced my problem down. Now I'm just going to use the 2 minus I and do the same process. Add down, that's 1. Multiply diagonal, that's 2 minus I. Now what happens here that's kind of nice is those i's cancel. And so all I have is 1 plus 2 is 3. And then multiply diagonal, 2 minus I times 3. That gives me 6 minus 3I. And again, that's kind of cool because that drops out. Negative 16 plus 6 is negative 10. I multiply diagonal, negative 20 plus 10I. And all that cancels out, I get 0. But I knew I was going to get 0. We knew that was a 0. And so we're in pretty good shape here. We've reduced the problem down. Remember what we started with, though. We started with x to the 4th. So when we reduced it down the first time, we would have had x to the 3rd. And then when we reduced it down the second time, we reduced it to x squared. So what I'm looking at here is 1x squared plus 3x minus 10. And that is something that you should know how to factor. I call that an easy trinomial. Numbers are multiplied to 10. And one of them's negative. They're going to add up to 3. That's a negative 2. Negative 2 plus 5. Those are your factors. But we don't want factors. We want zeros, right? And the zeros, here's one of them. And here's another one. And then 2 would make 0, and negative 5 would make 0. So I've got 4 zeros. They are 2, negative 5, 2 plus I, and 2 minus I. Or I suppose you could see it written as 2, negative 5, and then 2 plus or minus I. You might see it written like that. I think it's more comfortable if we see it written like this. Descartes' rule of signs. Let f of x be a polynomial with real coefficients and a non-zero constant term with terms in descending powers of x. Then the number of positive real zeros is the number of sign changes of f of x or less by an even number. When they say or less by an even number, if you find that there are 4, then what that really means is subtract 2 or subtract 4. It's 4 or 2 or 0. If you find the number is 3, then you can subtract 2 and get 1. If you find that the number is 6, then it's going to be 6 or 4 or 2 or 0. You're saying that's the number or less by an even number. So basically subtract 2, 4, 6, whatever. If the number was 5, you can subtract 2 and get 3. You can subtract 2 again and get 1. You won't have a negative, though. So anyway, that's kind of what that means. I know that looks complicated, but it's actually easier than it sounds. The number of negative real zeros is the number of sign changes of f of negative x or less by an even number. All right, so I know that seems complicated, but check it out. It's not that bad. F of x. See how this is negative on your first term, and then your second term is positive 3, negative 5, positive 4, negative 1. Sign change. Right here is a sign change. It goes from negative to positive, changes to negative, changes to positive, changes to negative. I see 4 sign changes. So the number of positive real zeros is 4 or 2 or 0. That's it. For the negative, though, you've got a little bit of setup to do. For the negative real zeros, we have to look at f of negative x. And see right here where it says f of negative x. Then what I want to do is replace my x with a negative x. Negative 2 times negative x to the 4th plus 3 times negative x to the 3rd minus 5 times negative x squared plus 4 times negative x minus 1. All right, now, it's not quite as obvious as the last one, but look at each of your terms. I have a negative and then 1, 2, 3, 4 more negatives once I take it to the 4th power. That's 5 negatives, which will be negative. In the second term, I've got 1, 2, 3 negatives, which is still negative. In the next term, I've got this negative 5, and then I've got negative squared. That's going to be 3 negatives. That's still negative. In the next term, I've only got 1 negative that's negative, and then negative 1 is negative. So if you look at it, there are no sign changes. It's negative, it's negative, it's negative, it's always negative. So the number of, what does it say? The number of negative real zeros, there aren't any sign changes, so that's 0. I know that's tough to understand. That's why we're going to do another example here. Let's try this next one. So for positive real zeros, all we have to do is look at the original. Look at f of x. This is a positive coefficient, negative, negative, positive, negative. So sign change, sign change, sign change. There are 3 or 1. Remember, you take that number of sign changes, and then subtract 2, basically until you get down to 0 or negative. You got 3 or 1. For the negatives, you have to look at f of negative x. So all that means is replace your x with a negative x to the 4th power minus negative x to the 3rd power minus 17 times negative x squared plus 55 times negative x minus 50. All right, now the first term, you've got 1, 2, 3, 4 negatives. That's positive. And then you've got this negative in the front, but then 1, 2, 3 more negatives. That's 4 negatives. That's positive. A negative here, and then squared, that's 3 negatives, so that's negative. This one only has 1 negative, so that's negative. This one has 1 negative, so it's negative. I only see 1 sign change right there. It goes from positive to negative right there. It changes. So the number of negative real zeros is 1.